The next functional group we're going to talk about are the ethers. And I mentioned when we talked about alcohols that alcohols are often the starting point for other compounds that you're going to make. And that is very definitely the case for the ethers, because an ether, the way I look at it, it's almost like an oxygen bridge almost between two other groups. The R on one side is one group, and I have an R prime on this side because it could be a different group than the one that's over here. It could also be the same group that's over here, in which case it would just be an R. But I put an R prime up there just so you would know that it could be a different group. Ethers are prepared by taking two alcohols and combining them in the presence of sulfuric acid and heating it up. And when you do that, you cause what's called a dehydration reaction. And all that means is that you're going to remove water from it. And so basically what happens is that I'm going to take this OH group over here and the hydrogen off of this OH group over here, and I'm going to combine them together. And then this bond is going to connect to this oxygen, which leaves me this ether on this side. And then here the H and the OH come together and they make water over here. So that's a dehydration reaction. You're going to see lots of them in this module as we're making different kinds of compounds. Okay, so two alcohols are going to combine together to make an ether here's the R group on one side, and then here's the R prime group on the other side. Now, when you name these, the IUPAC system, it seems to be a little flaky when we go through and we're naming some of these. So there's actually two different ways you can name them, and I will show you both ways, and you can pick whichever one you like best. Okay, so this group here, here's my oxygen bridge. I have an ethyl group on one side and a cyclopropyl group on the other side. So I could name this as F-oxy cyclopropane is one way to name it, whereas this, I'm calling this the oxy part, F-oxy cyclopropane, or, and I actually kind of like this way better just because I think it's easier, I take the two sides, put them in alphabetical order, and then call it an ether. So this one I would call cyclopropyl ethyl ether. Cyclopropyl ethyl ether. Okay, so either way is okay. You can name it whichever convention you please. Okay, so here, this is an example where I have the same group on each side. So if I use the first convention, I would name this as F-oxy ethane. So that's one way to name it. Or I could name it, since there are two of the same, I could name it as diethyl ether. Okay, again, either one is fine, whichever one you like. Okay, then on this one, I have an ethyl group on one side and a methyl group on the other side. So if I'm going to name it in alphabetical order, I would name this one as ethoxy methane. So here's the ethoxy, and then here's the methane. Notice they're in alphabetical order. Or I can name it as ethyl methyl ether. And again, these two are in alphabetical order. Ethyl methyl ether. Okay? Here I have two benzene rings hooked together by this oxygen bridge in an ether group. So again, two ways to name it. I could name it as, remember that a benzene ring, we often name it as a phenyl group. So I could call this phenoxy benzene, or I could name it as diphenyl ether. Okay, so there you can see several examples of how we name ethers, and you can see the how we form an ether by reacting two alcohols together. So that is going to conclude our discussion on ethers.